Okay, hi everyone. Welcome to Always Coding, our weekly hacky hour. I am Komal Devjani, a developer advocate with alwaysAI, and I'm joined here by Laila Milani, who is also on the developer advocacy team. Hi, Laila. Thanks for joining us. And today's topic is focused on interactive data set generation using Flask and alwaysAI. So before we get into that, just a couple of pointers for you. If you have any questions, this is intended to be an interactive session between our internal engineers as well as the developers within our community. So if you have any questions at any point, feel free to raise your hand. We can call on you. You can unmute yourself, or you can use the Q&A button and we can take pauses to address some of the questions you have while we go into the demo. So as always, I'm just gonna set up by showing you how to get started with alwaysAI. So if you haven't done so already, you want to sign up for alwaysAI, and you do that by going to alwaysai.co. And if you haven't signed up, sign up. If you have signed up, go ahead and sign in and navigate into your dashboard. And here, if you haven't done so already, I remind everyone every week, because this is the most important part of using alwaysAI, is you need to install the alwaysAI once you've signed up. So you have the CLI install instructions available here. So you can click install CLI, pick your operating system. I'm using Mac, of course, hit next, and you'll see a big red button that says download for Mac OS, and you can go from there. You will get an unidentified developer pop-up warning, but you can simply bypass that if you're using Mac just by opening it in your Finder. So with that said, I'm just going to show you how it'll work. So today we're just going to run an existing project that I've created. It's a sample app with the MobileNet SSD Cocoa model. So let's just use that. And if you haven't downloaded the CLI using dashboard, you can download it here again once you've created a project. So let's just copy this command here. As you can see, I already have my model added here, and we're going to go on to the terminal. Now I'm going to navigate into my directory. Oh, sorry. And then let's just go ahead and paste this command, and this will configure the project on my machine. And I want to save this on my local computer. And I've already specified that I want to use this model in my app.py files. That's also an important component if you want to launch an app. So since we've done that already, we're just going to do AAI app install. And then we can do AAI app start. And we're just going to copy this link and then paste it into a new tab in our browser. And you can see that this can detect me as a person. It can detect like all of my plants right there. And that's how you know your app and your CLI is working. So we're going to stop this right here. But if anyone has any questions about how to set up a project or how to add a model to your project, feel free to raise your hand, or if you have any comments, just let me know. Now, of course, we know that generating a data set is the most critical part of computer vision model training. And Lida here has prepared a demo for us to show you how you can do an interactive data set generation session using Flask and alwaysAI. So Lila, I'm going to hand it over to you now.
Thanks. Yeah, so as Kwon mentioned, it's very important to generate your own data set. And another important part of that is that if you're generating a data set to train your own model, you might want to have that data set be in the environment that you're going to run that model. Maybe it's pain to walk around with like an iPhone camera. Maybe you don't want to use an iPhone camera to inference on, so you want to use the camera that will actually be running the app itself, maybe like a Raspberry Pi camera or a webcam. So this app is designed so that you can deploy a data generation app on an edge device and out in the world, and it will store your images and video files on that edge device, and then you can retrieve them off that device and use them to train your model. So you can also, of course, run it on your regular development machine, and I'll show both ways. And so the other component of that is that it's an interactive application, as Kamal mentioned, which means that you decide when you want to take photos or videos. So you don't have to just set it up like AI app start and then it's just collecting from the get-go. So another possible component of that is maybe, you're wanting to train a model on a few different data sets, and you have a bunch of images from either ones, or maybe you're combining them. You could add a component to this to set it on like a timer, or maybe even add in some object detection to detect, maybe you see a bird, maybe you want other stuff in the application with that bird or something like that. So you want it with the birds, but you're going to be annotating something else. It's a little fuzzy of an edge case or a use case here, but the idea is that as long as you have this data generation app worked into your AI, alwaysAI workflow, then you have a lot of flexibility in how you use it, how you work it into your model training, your annotation process. So that's kind of fun. And the other aspect of this is that even if you didn't want to build your own data generation app, this will enable you to build your own kind of little alwaysAI server with your own buttons. Maybe you want to customize it, add some extra features in there. And we've had some questions on Discord in the past. And Eric had another application on the GitHub that has a more like client server architecture that I'll point out when we go to GitHub. This one fits the Flask server in your alwaysAI app. So you just have to start up one application and you're good to go. Okay, so Kamal pasted that GitHub URL. So I'm just gonna share my screen. Oh, and I always forget to ask before we start this, can you enable screen sharing?
All there good. I always forget to like.
I know, every time. Okay, so we'll share that. Can you guys see my
yeah, we can
GitHub? Okay, so here's the alwaysAI GitHub. This is the one that we're going to look for, but the other one is this video streamer multi-container. So this was the original one Eric made. It has the computer vision application and then the server here, and they talk to each other. And you can use Docker Compose Up to start up the two different containers. And this is really useful. Maybe you want your data generation application to be on multiple edge devices. So you could follow this type of architecture if you want to have a more like widespread approach. But for this one, this is the repo we're going to use. So you can go ahead and clone it by copying this URL, or just download it if you'd prefer to download the zip and not have it with your GitHub. And in the interest of time, I have already downloaded everything, but git clone and then that URL. So I have two repos set up here. This one is just going to be the one we're going to run on our desktop. So I also already configured it, but as Kamama showed, you do AI app configure and local. Okay. So first, I'm just going to demo this so you guys can see kind of what I'm talking about, and then we can explore the code and see it on the Pi. Hopefully, everything will be happy. Okay. Okay, so you can see the buttons here. Snapshot, start collection, stop collection. Okay, so we can take a snapshot and say snapshot saved. We can start collection and maybe move around a little bit. Stop, and it'll update here. And then we can stop it here, and you can see it stopped, data collection stopped. And then when we Control C, it will actually end the program. And so I tried to make this very similar to your standard alwaysAI app. So it has a lot of the familiar print statements, and you can see everything that was printed out here on the streamer is printed out here. And what happens in your actual folder directory here is this, yeah, that's the right one. So you have this little file here called, or folder called samples, and that will be where all your data will end up being stored. This is a timestamp. Looks a little funny. You can obviously change that if you want a different type, but this is a unique kind of session. So I'll start it up again in another minute, but you can see because we took images, there's an image and there's videos. These will be stored as a JPEG. that's just kind of standard, and that's the format we use for model training. So that's a good note to make. This AVI, this is a standard kind of output for the alwaysAI video streamer. And you can open it up and it works just fine. And here I am moving around. So the other cool thing about this app, I mentioned that it's a session. Let's just start it again. Wait for it. Okay, so here, we're gonna take another video, stop it, Control C, and then we've got a new session. And we only took a video this time. So now it's stored under this video folder, and we've got a new video. Maybe I should have done something else because now, I've moved around in both of them. Looks like the same one, but they're different. So that's kind of cool. You can save multiple instances and everything will be stored. Are there any questions at the moment?
No questions yet, but yeah, feel free to write out your questions if you have any, or wave your hand.
Yeah, interrupt me, whatever you'd like. So that's nice. It's an interactive thing, but the main point is that you want to be able to run this stuff on an edge device, so we can do that as well. So this is just, I cloned the repo again in a new folder, and this time I configured it for my Pi because I had to pull the Docker image. That takes a while. I didn't want to have you guys just sitting here doing nothing. So let's just make sure that it's still okay. Hopefully my Pi hasn't gone to sleep or anything like that. Okay, so I've saved my devices before. Let's see, looking good. Okay. Okay. Getting there. Well, I guess while that's doing its thing, it's going to take a minute. I probably could have just run it without it. I can start. Oh, it's making some progress. No models. Oh, see, that's the other thing. I didn't add any models to this application, but you easily can, just like any other thing. It works perfectly well with all the Edge IQ and model catalog. So if you just so happen to want to run object detection, you could add that into your app there. Okay, that's good. This guy always takes a minute. Okay. Okay, so now you can see a different camera, my little webcam here. So now we're going to start collection. Data collection has started. Bye. And we'll stop. Okay, and now you'll see in this folder here, there's obviously not a new data set collection because I ran it on my Pi, and it's no longer there. Well, it never was there. So what you need to do is you need to look on the Pi itself. So we can SSH into Pi. And I'm using .local because I'm on a Mac, but if you're on a Windows, you don't need that. And of course, if you've named your device something else, then you can call it something else. Okay, so here, I'm pretty sure that it's just an alwaysAI. Here. Okay, and samples. I did run this before, so we've got a few samples, but you can see, can you guys see this console okay? The colors
Yeah.
all right?
Can you make it a little bit bigger?
Yes. Is that a little bit better? Even bigger, maybe?
Yes.
It's probably I made everything purple. Doesn't really work now that I'm logged into the Pi. It looks a little funny, but we'll go into this guy. This is the newest one. And we can see that I just took a video again, so there's only videos there. If we went back up into 08, 02 something, 3. Sorry. 8. Okay. This one had there. Sorry, guys. Okay, this one had images and videos. But we're going to check out this one. This is the latest one. Okay, so here we've got this movie. And what I can do now is exit out of this SSH. And instead, what we're going to do is secure copy SCP. Let's see. It was pi at alwaysAI.local. I think it was home pi. Samples. Sorry, guys. This is a slow, kind of boring process.
All good.
But it has to be done. I know.
Informative.
Oh, wait, do one. Videos. Did I do it right? Let's see. Nope, I didn't do it right. Okay. 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 That's what I should have done from the beginning. Okay, so you're going to secure copy pi at alwaysAI.local. Then this URL plus this file name here. Okay, that worked. Sorry about that. So what we need to do is go into my Pi, and now we have this video, and we can check it out. So there's me just talking. So that's kind of cool. You can have all your videos stored on your edge device, which is also kind of neat. Possibly a little bit more secure than constantly. I mean, obviously I just copied them over the net, but you could go collect your Pi in person, and then you don't have to send everything over the cloud all the time, constantly live time. You can do it later on a secure network, whatever you think. And if you had model training or something running, or object detection, I mean, then that wouldn't have to get sent back up to the cloud to your local host. Everything runs on the Pi, which is kind of neat. So how are we doing for questions? Are we okay, or do we have any?
Still good. And does anyone have any questions? I think we're okay to keep moving forward.
Okay, nice. So we'll check out the code. We have your standard files here, everything you're used to. So we'll open these guys. Sorry, make it a little smaller. Okay, so I don't know how familiar people are with Flask in general, but Flask is a pretty lightweight framework for developing web applications. So we used it very minimally in this application, but a lot of applications are built around Flask. You can add in forms and authentication. It does a lot of, it makes it a lot easier. You don't have to worry quite so much about security and that kind of thing, especially if you're doing like database. It has a lot of safety measures kind of worked into database updates and whatnot like that. So I'm not going to get too into the Flask details because this is an alwaysAI hacky hour, but I just want to give you a little like background in case you're not familiar with it, what we're doing. So one of the main differences with this app is that you have a lot more import statements, and that also corresponds to, maybe I even opened this one already. Yeah, I did. So like, okay, these are some pretty standard, well, not all of them, pretty standard Flask stuff. Flask, Flask.io, this WorkZug, it's like a security kind of thing. Jinja, that's the HTML kind of templating language that's used with Flask. A lot of this stuff. And then some of the other stuff in this requirements.txt are necessary for the threading that we used in this application to have the data stream coming, like that's being sent to the streamer so you can see what you're doing, like how most alwaysAI apps run. So that's kind of running constantly its own thread. And then let's see, some of these other ones are installed, like requests is how we get, sorry, I'm totally blanking, how we get like kind of like the socket stuff worked in. Okay, so let's go through some of the like anatomy of this application.
Hey, before we do that, is it okay if we stop for a question?
Yeah, definitely. Sorry.
First of all, AB said great app, so thanks. And then Dale Hitt from iCloud, he's asking if you want to use the image capture video to update the training of a model. So I imagine it's updating the data set to train a model. What is the path to do that?
So this is just the data collection portion. So what you would do is you would run this app, use it to collect whatever data you want. Then you would have to annotate that data using, we have the tooling built into alwaysAI, so you can do AAI annotate and use CVAT to to annotate the images that you've collected. Then you would export that and then send it on for training. So it's a little, you know, it's a little strange when you think, usually if you were going to, my thinking is that if you were going to use this specifically with some sort of object detection model, you could run it against another model, maybe like one model that detects bears, another model that detects trees. You want your model to detect both. So you're maybe having this worked in where your data generation app will, instead of me clicking a button to be like, take a picture now, it will be like, oh, I see a bear and a tree, I'll take a picture. And so it would just be taking pictures whenever you see kind of like an aggregate of all the stuff you want to train, and then you could annotate it yourself. There's a bit of a space for model training assisted annotation where it actually makes the bounding boxes, but this was my sort of thinking, is that if you wanted to kind of assist you in like building a more specific model, like retraining using existing models, that this would kind of work in that sort of sense. Maybe it wouldn't really work in the sense where a model already detects a bear, so you want to train a bear. It would have to be something where you're expanding the use case. But this is just the data generation. you then have to annotate it and then feed it into the training. Did I answer the question, or was it, are you looking for something else?
I think it was pretty informative. If it's helpful, also Dale, I can provide the links to our model training webinar that we did a couple weeks ago, as well as a data annotation hacky hour that we did shortly after. So that should provide you with some information about how to move forward with taking your data set and annotating it and then training a model.
Yeah, good point. Yeah. And on our docs page, you can find our quick start guide, and that uses this app as a starting point, and then we'll walk you through some of the other process once you've gone through that hacky hour and data annotation, kind of found your footing in terms of the research there. Nice. Do we have any other questions?
Nope, but Dale said thanks.
Okay, great. Thanks. Okay, so let's see. There's a few different things going on here. We've got the regular computer vision application, and I borrowed this from Eric's original app with the server and the CV application with the server and the separate containers. So a lot of that detail comes from that, and then I just slightly modified it. I'll try to be as linear as possible, so forgive me if I jump around, and if at any time I'm not making sense or being confusing, please do interrupt. So basically we have this CV client. This is what is streaming, and it's called CV client in a sense because I did borrow it from Eric and it was using object detection. Now we're not really using it, so it's not really computer vision, but it is kind of computer vision. So that's why it's called CV client, if anyone was wondering. Sorry if that's confusing. So this is something Eric helped me out with. We had it inherit from the thread class so that it could run in its own thread and constantly be running and not have to worry about getting interrupted. That's where this exit event comes in. And let's see, this super, that's what that's doing there. It's calling the super initiation constructor. Thank you. So this is probably fairly familiar if you use alwaysAI. Because it's a thread, I put it in the run method. That's what will, when the thread is started, this is what will be executed. So this is kind of that core alwaysAI workflow where you start your video stream. This is the socket. I will come back to that. Start the FPS. Then we're reading in constantly. What we're doing is we're reading in, and this is all on its own thread. Reading in, I chose to refresh the text instead of appending to it, which is why I started it here. If you want more of a log, it can get big pretty fast, but you could have it just append to it. And I'll also come back to this. This is a writer class that I made for this so that we could kind of keep track of state a little bit better. Because everything is happening in this one little box. It's using a lot of sockets. And so what happens with this writer is this writer kind of gets pinged with a certain state and then holds that state until something else pings it. And that kind of just helps keep track of things a little bit better. Okay, so the way the image capture and the video work is that they're constantly being appended to this queue. And if you are not familiar with queues, it's a first in, let's see, I always get this back. First in, last out. Last in, first out, whichever way you like to say it. So that means that if it's a way of saying, so if something's on the top, if I want to take an image, I can just pop that image off the top that just happened and I want to store it. Versus a video, I can just keep popping and it will have all the frames that came as it's happening. Does that make sense? So this is what it's also using that state. If it's true, then we're going to keep appending it to the video frames. We always append everything to all frames. That's so that we have this kind of record. But if the video button has been pushed, then we're appending things on to the video frame so that then we can pop them off the video frame later. And that way we just get a little snippet versus having to try and find a timestamp or line things up. So in any case, anytime we get a frame, we always append it to all frames. If we're writing a video, then we'll also append it to the video frames. And those, I should have started, those were initiated up in here. These are part of the CV client constructor, and they're set to, this DQ is a more efficient way of popping a queue in Python. Okay, so then regardless, we just update the frame like we do always in our apps to the streamer and the text, and then update the FPS, and we check if we need to stop. So this check exit is a kind of customized check exit, and it is somewhere, I'm sure. Where are we doing? Self.check exit. Sorry. This is, the other thing is I put most things in this one file. It might have been a little bit cleaner code to separate some things out. Let's see if I can just find it. If I can type. Check exit. Okay. It just checks this writer that is storing this state. So now I've talked about the writer quite a bit. Let's just look at it. It's very, very simple. It just has two Booleans, write, close, and text. So if it's writing, it's true. And if it's not writing, it's false. And if it's closed, close is true. And if not, it's false. And then the text is how we get this data collection ended, data collection started. That's kind of like a state. It holds the state for the text. Are we still doing okay for now? Okay.
Yeah.
Nice. Okay, so that's the CV client. It's pretty basic. So it's constantly reading in the frames. It's appending them to all frames or video frames, and it's using the writer object to determine, am I still going? Am I writing to a video? Am I not? And that's pretty much it. This is also part of Eric's original code. The frame needs to be converted to bytes. It's just like a logistics sort of thing. And the send data is the next big part. That is going to be using the sockets. So next we can kind of go into the sockets and what they're doing. His uses two different sockets on two different, I think he does, two different URL endpoints. This one uses just one, so we have to add these sleeps in to kind of interrupt things and make sure that the socket can receive messages. So if you see these really, really tiny sleeps, that's what that's doing. So the send data is a way to get the video stream. Oh, where is it? Video stream. Where is my video stream? Sorry, bear with me. Okay, nope. Up. Okay, this is my one video stream. This webcam video stream start. It's everything will be using it, and so that was also a little funny. Originally, I had multiple video streamers being instantiated, and that was not the way to go. So this is the way we went. We used one, and we added in these sleeps, and we added in this. That's why we used the queue too, to have just everything be on this one stored frame, and then the webcam video stream can just use that queue, but we're just popping things on and off, or using the video stream queue. So I'm sorry, that was a bit of a tangent. I just didn't want to forget that bit. Okay, so what we do here in the send data is, and this, pretty much I just stole it from Eric, if I'm being honest. I just stole it. And I just changed this socket IO sleep. But it's emitting this message. And if you're not familiar with sockets, there's like broadcast, which broadcasts to all channels. You can specify the channel you want. So it's emitting this message specifically to this endpoint, server to web, and it's sending the converted image in bytes and this text. So let's check out what that is doing. And sorry again for this other little tangent. With Flask, and probably other web development, it's typical that you have these two folders, static and templates. And static holds your CSS files. That's like how you design web pages, and it holds images and that kind of thing. And then templates is where you put all of your HTML code. So this is an HTML file, and if you just open it, it will actually open in the web browser. So we'll just open it here, and it's full of stuff, and you don't need to know all of it. A lot of this, if you're not familiar with HTML, a lot of this is just kind of like what's the word? Like just startup stuff you need. Links to packages, Bootstrap packages, or like formatting things, a lot of library loading and that kind of stuff. This is the style section. This is, if it was getting really big and it was an actual big web project, this would be a CSS file, and you would put that in the static as well. So this is what we want, the body. And I stole this from Eric as well. I just copied it from that GitHub. And that's kind of the cool thing about our GitHub, is that you can just take somebody's project and tweak it, and you don't have to build every little thing from the ground up. But this is all fairly standard stuff. Obviously, he's linking to like our documentation and support. Okay, let's see. This is really the stuff that I added. I added myself a little Bootstrap container, and I labeled it. And then these are my buttons, the 3 little buttons you see here. Take a snapshot, start collection, stop collection. So you could add your own buttons, if you want to do something else. All you need to do is make the actual button, give it an ID, and then you have to write a function that looks for that ID and does something with it. So I'll show you how I did that, and you can just do your own function if you want to do something else. You could have it have a pop-up, you could have it text something with Twilio, or actually use like a database, anything you want. Okay, so this is where the actual functions go. This is kind of like a startup sort of thing. So whenever the web page is loaded, do all this stuff. So you can see we're creating some variables here, and this is the stuff that Eric already had, and this is stuff that I added. So I think the stop app I changed that, but that's the standard. This is that little button up here. So this get element by ID is how you see these have an ID here. And I'm sorry if people know this. If everyone's really sick of it, you can tell me to just move on. But if you don't know it, then it might be useful to know. You have an ID here. Sorry, what?
I said it's a good refresher.
Okay, good. If you have this ID here, then you can grab these different elements. This button is an element by its ID, and save it as the variable itself. And then you can use that variable to add event listeners. And this means that it's listening for this click. I've clicked this button. You can also do like mouse over, mouse on up, mouse on down. And I'm pretty sure that might be like, I might be flashing back to my Java days or something, but the principle is there. It's some sort of action, and you're listening for it. And this is like JavaScript syntax. It's a little funny if you're not using it. And I missed a couple of these little semicolons. Sometimes they matter, sometimes they don't. I guess it didn't matter here, but you caught me. That was my bad. Okay, so this is just console log. That's just debugging kind of statements, making sure that things worked. So here's what actually happens. Socket emit, close app. Socket emit, stop writing. Socket emit, write data, or take snapshot. So those are what's actually responding back to the app.py file. This is what socket on this event server to web instead of on event listener. When it gets this, it's going to update image element, which we saw is up here, and it has the ID streamer image, which is this guy. So, and you can even see if you right click here, you know what I should have done? Should have done that. See, streamer image. So this is, sorry, this is like really squashed, but you can see streamer image is that image. So this is what it's updating when it updates that. And you can see these are the buttons. So that's kind of handy. Now you can see like what it's actually doing and which elements it's looking for. Okay, so
actually, Lila, we have another question. This one's also from Dale. So he's saying that this is frame-based capture. What if the camera provides the video compressed over a TCP/IP connection? Maybe it's like RTSP/ONBIF, stored directly or compressed. Do you compress it to frame by frame for inference processing?
That's a good question. I am not really sure. I haven't thought about it. It's like Steve or Eric, do they want to take a crack at it? Otherwise, I can definitely think more about that and get to you offline.
Steve is on. I don't know if he's active. Steve, are you there?
Yes, I am. So what was the question again? Sorry.
Hey, so this is a question by Dale. He's asking, what if the camera provides video compressed over a TCP/IP connection? And then he's saying, do you decompress it to frame by frame for inference processing? Is it? And then he's saying, is it stored directly?
Yes, we do.
Okay.
Nice.
Okay.
Thanks, Steve.
Right. Yeah, thank you, Steve.
You have to know what's in the. You have to decompress the frame. Yeah, the inference engines will not work on a compressed frame. So
that makes sense. Yeah, you know, we can. This is
you can buffer, of course, coming in. That's on that piece. So
that's true. Yeah. Yeah, good question. That was an interesting one. I hadn't thought about that.
Thanks, Steve.
Are there? Yeah, thank you, Steve. Are there any other questions?
No, there's no other questions.
Okay, so yes, it gets the message. The message that was sent was this dictionary. It pulls out. Let's find it again. Pulls out the image, pulls out the text. Image, text, and then sets the element. Where is it? Sets this to be that content and the text. Yes, which you wouldn't, the inner edge HTML. So that's the here. See the source and then inner HTML. I think that actually would be nothing. That makes sense. Okay. Okay, so now we've covered kind of the front end. Let's take a look at how the sockets work on the back end. So this is the home page. This / is always the home page, and it just renders this HTML, this index.html. Connect, it just makes these print statements. We saw that right here. And then, okay, so on write data, that is when socket emit write data. That's when the start button was clicked. So on write data, we have this controller StartWriter. Oh, and I haven't described the controller class to you, so forgive me, I'll do that now. That's kind of, there is a bit of a linear thing to this, but you can't go straight there. We're gonna have to jump back and forth a little bit. So the controller has the CV client, it has an instance of the CV client as one of its attributes. It also has an FPS instance and the writer, an instance of the writer class. Self.write equals walls. Yeah, okay, no, sorry, that's its own writer, or write Boolean. It's not the writer class. And I probably should have named it something different now that I'm thinking about it. Okay, so when it starts the Flask app. This is the port, this is localhost. So it starts the Flask app and it starts the CV client, and that is this start is the run it's running in its own thread, and so it's just up and going. Then the close will stop the FPS. It will also check if that thread is still alive, and if it is, it joins it up with the main program and closes it, or vice versa. And then you get this print statement program ending, which we get when we actually Control C. So you can see the stop signals received when we press that button, and then Control C program ending. And that is also when this function is called. Sorry to jump around again. That's the exit event is set. Okay. That's the terminology that the thread library uses to close out a thread, and then you join it with the main program. Okay, so it also accesses the writer that's in the CVC client, or CV client, sorry, and that is how it kind of knows, am I writing, am I not writing? And this is a little messy. It probably would have been better to call a function on the CV client that actually checks this and returns it, but I just access it directly because it's all in one little program. So I know that that's not as clean as it could be, but that's how it is. Okay, so you can see this controller. There's one instance of the controller, just kind of a global variable in here, and it starts when main is run, and that's what starts the CV client and starts the Flask app. So that's how we get the Flask app all into one little package. When the main program's run, the controller starts up the Flask app, and then starts up the streamer. Okay, now that we've covered the controller, I'll go back to the sockets. Sorry for that little detour. So I believe we were on write data. So we start the writer. That means that the writer, the CV client's writer is now set to true. So we know that we're writing on start data collection. That's just managing that state to make sure that we know that the writer is writing. And that's also how we know to keep appending it here to the video frames. The writer is true. The writer's write status is true. So we're appending to the video frames. And that means that, so every frame that comes in gets appended to all frames, but it also gets appended to video frames. So it's appending, and then when we stop collection, we'll start writing it off, and we'll start it by popping it, and that's why you get the order that you need. I think that was reversed. Okay, so we'll come back to that when we do the stop writing function. But so we've got some sleeps in here. This might be kind of like, you could play around with it, and maybe I didn't do them exactly how they should have been done. It was kind of hit or miss, like trying to figure out what made the sockets be able to receive the messages. So it could be that a couple are left in there that aren't necessary. I'll admit that it was a little bit of trial and error there. So that's usually why I put them in, is that I needed a pause to update that state and check things so that the proper flow, like the order of operations, was there. So we update the text. You saw that data collection started. We print it too, just for good measure. And then we use this file setup using this session. And I know I mentioned the session way back in the beginning, but I forgot to describe it here. This is just like a timestamp. Every time the app is started, it gets a new timestamp, and that's the folder name. So you can have multiple sessions stored in their own unique spot and then pull them out. So this helpers has this file setup, and it's just kind of long and messy. It makes the proper directories if they don't exist. So it makes the samples one if that doesn't exist. If it does exist, but the video folder doesn't exist or the image folder doesn't exist, it creates that. And you can see it's passed in the sample types. That's either video or image, and the session. So it just does some if else. It's not the most elegant thing, but then it returns the name of the file that you're going to use, and that is used for your video writing or your image writing. And it will either have, JPEG or AVI, depending on if it's an image or video. So once you get your file name, then you just write out using the EdgeIQ video writer. And this stuff, most of the stuff, I slightly modified it. I believe it was Andres who wrote the original data collection app, which was just an app.py and just had like this in it. And then we fit it into the Flask app. So it's just checking that the sample rate you have is, it can't be greater than the FPS, and it's pausing sometimes to make sure that it's getting the proper flow down. This is the stuff I've added that and you can see we have a couple of these socket sleeps again. So that's if you press the stop button, it will get that message. And so it's always checking that if this controller is writing, is checking that CV client writer state for have we stopped writing. And if it has stopped writing, then we're going to update the text. We're going to break out of this, and then the stop writing will set that the stop writing sets the variable that this one checks for, and then it will wait for another signal. And so the actual writing is using that popping functionality that I mentioned. So it's just taking all the video frames that were stored and popping them off. So once we clicked start collection, it started enqueuing them. And then when we pressed stop collection, when we pressed start collection, it started enqueuing them. And then this function dequeued them. And then as soon as we've stopped collection, it will stop dequeuing them, and it will just pick up where we left off the next time somebody presses start collection. I'm sorry if that was a little confusing. Are we okay for questions? Or
I think actually Dale wants to elaborate on his question about compressed video stream.
Sure, yeah.
I'm gonna unmute him. Dale, are you there?
I am here.
Hey.
Hey there. So yeah, I noticed you're popping frames out of a camera, and I'm wondering when the camera is remote and sending the data compressed over IP, how that looks like, whether it's.
Yeah, I haven't tried that myself. I don't know if anyone else has and they know what that would be like.
'Cause it's common for remote cameras to send the data compressed over an IP stream. So I'm just wondering how that connects into the alwaysAI framework.
Yeah, I can research that a bit and get back to you. We can post it on Discord or something, unless somebody else is online and
I'm
happens
sure
to know
he's
and wants to answer it.
dealt with this because it's common.
Maybe we can try Steve. Steve?
Yeah, so you'd be better off if Taiga's on. Taiga's handle the IP streaming. What I can say is if they're compressing, it's happening down, Dale, at the IP level, the compression and decompressioning on the TCP IP stack itself. You're out of my domain now. I can talk about inferencing engines and so forth, but I'd have to go over directly to Taiga, who we do have that a streamer implemented, so for cameras to stream,
Right.
so forth. That implementation nuances that you're asking, that's a very good question for us to take to Taiga and get back.
Yeah, that would be better.
Yeah, so it's a good question. Now, when you wrote your second one, I understood what you were talking about, but I just don't know the nuances.
All right, thanks. Just let me know.
Yep.
Thanks, Steve. Thanks, Dale.
Yeah, thanks, guys. Okay, so we're kind of coming up on time. So basically, I think we've covered start reading, stop reading. Take snapshot is very much the same. It gets the image and it just pops off the last frame. It doesn't need more than that. So it's the simplified version of the video writer. Instead of keep writing, just write once. And I just use CV2 for that. And then CV2 imwrite. And then close. You close the writer. We can visit that guy real quick. That just sets the writer to false and closes the writer. And that's just setting it to true. And then I think we've covered most of the functionality that we needed to. I can't think of anything else. that we didn't add. Yeah, so I think that wraps it up pretty much for this app. You can change it. Obviously, you could have it write to a database. You could have it use data frames if you wanted more like CSV logs of things that you'd encountered or some sort of record. You could have it have different buttons, different functionality. I don't know. It's kind of a versatile thing. It's kind of fun, and yeah, hopefully that's helpful for people. If you want to check out the quick start guide on the model training docs, then it will kind of walk you through using this and then exporting your data and then using AI annotate to annotate your data and then train a model.
Sweet. Thank you so much, Lila. And yeah, definitely. So I've posted the GitHub already on the chat, but I've also sent it to you via email. And I'll just send a replay of this Hacky Hour so you can take a look at it afterwards. And Lila, I just love having you on Hacky Hour because I feel like I learned a lot from you. I hope that's true of the attendees as well.
Thanks, Kamal. Sorry if sometimes it's kind of scatterbrained coding day, but I have fun. I love doing these, so hopefully you guys also have fun, and hopefully you do learn something. And it was a tough week to follow AB last week, so hopefully I did him proud. Hopefully he'll come back on and do something else. It's always fun to be the student on the Hacky Hour and not the demonstrator.
No, it's so great. And then he just responds saying, haha, with a smiley face. No, I think it was super informative. And again, thank you so much for joining. And thank you for.
Yeah, thank you guys. Thanks for coming. Yeah.
Okay, so I have a couple of announcements for everyone. So we are going to be launching model training for Windows. So keep an eye out for an email coming out in a couple of days. And now if you saw our model training webinar, you can now do the same thing if you have a Windows machine. So give that a go once it's ready. Next week at Hacky Hour, we're going to be reviewing how to create computer vision applications using TensorRT models. And that's going to be hosted by Steve. So definitely join us for that. It's going to be same time, same place, 2 p.m. here on Zoom because we can't meet in person. And yeah, that wraps up my announcements for the day. And I hope you enjoyed the demo as much as I did. And I'll see you guys next week.